Good day everyone. Today we will tackle the chapter 10 of the Philippine Mechanical Code related to pumps. For the scope, this standard deals with the selection and installation of pumps supplying water for domestic, industrials, for private and or public fire protection. So items include water supply, suction, discharge, and auxiliary equipment, power supplies, electric drive control, internal combustion engine drive and control, acceptance test, operations, and maintenance. So this chapter does not contain system water supply capacity and pressure requirements. For the purpose of this standard is to provide a reasonable degree technical know-how and safety through installation requirements for pumps based on sound engineering principles, test data, and field experience. So guidelines are established for the design, installation, and maintenance for pumps, drivers, and associated equipment. So overhead supply. A water tank may be installed above the roof of the building or by separate tower for the purpose. So siguro nakakita na to og mga water tank. So kasagaran is gi-install nila above sa roof or separate tower. So parehaning na sa sample. So ang kaning water pump system is naa ni sila level sensors. Ang uban gagamit og float valve, ang uban is float switch. So para asa man ni sila. So kasagaran gigamit ang float valve for septic tank if I'm not mistaken. Then for water pump supply gyud is mga float switch. Ang float switch is automatic na siya mo on ug off. Mo paandar sa tubig. Kay connected naman siya daan sa na siya controller. So kung maubos na gani sa level ang tubig, automatic siya nga mupaagas. Then typical installation of a piping system. So this is the typical installation of a piping system. So naay check valve, gate valve, then foot valve and strainer. Para asa maning foot valve and strainer. So from the word strainer, so pangsaan siya. Then foot valve, mura ni siya check valve nga one direction. So ang tubig is kanang kasagaran gigamit ni siya if ang tubig is gikan sa underground. So kana one way ra siya aron nga kanang mapugngan ang pag-backflow sa tubig. So dili mo balik. Then gate valve, so siguro nakadungog naman taning gate valve kung unsa ni. So pwede nato siya i-able or i-closed. Then check valve, ang check valve is kuan na pod siya one directional. So mara siya pang safety para di ma-doubt ang mga pipelines, pump aron kanang tungod sa pag-backflow sa tubig. So when we say backflow means mo reverse ang direction sa tubig. So for the section 2.0 definitions, the pump today ranks second to the electric motor as the most widely used industrial machine. So the large variety of available pumps range from tiny adjustable displacement units to giants handling well over 100,000 gallons per minute. So let us define some words. So hydraulics or hydromechanics is the mechanics of water or other liquid whether at rest or in motion. Then hydrostatics, from the word hydro means water and statics at rest, so it is the science of water at rest. Then hydrokinetics, it is a science of water in motion. Hydrodynamics, it is generally associated with the science of the force exerted by water in motion, such as driving a turbine connected to an electric generator. Then atmospheric pressure, this is due to the weight of the atmosphere on the earth. And vacuum, a perfect vacuum is a space entirely devoid of gas, liquids, or solids. But since di man gyud na to mahimo nga kuhaan gyud tanan, so just for example, wa gyoy gas ang usa ka lugar or usa ka room na man gyud na siya. So the word vacuum therefore means partial vacuum lang. and is measured by the amount of its pressure below the prevailing atmospheric pressure. Then gauge pressure, so sige naman tagadungog ani. Gigamit ni kasagaran sa mga problems pud nga atong gipang solve. Then absolute pressure, it is the sum of the atmospheric pressure and the gauge pressure. So P-abs equals P ATM plus P gauge. Plus and minus P gauge, nga na siya. Then Bourdon gauge, it is the device most commonly used to measure pressure commercially. So mao ni siya ang Bourdon gauge. Then manometer, a U-tube containing a liquid of non-specific gravity, the surface of which moves proportionally to changes in pressure. So na-type sa manometer na open type na asay differential. Then pilot tube, so sa kasagarang ma-search is pitot tube ang nakabutang. So name for its inventor, pilot, is used to measure the pressure of water discharging from a nozzle or flowing in a pipe by having its open end in the water and the other end connected to a gauge or manometer. Then piezometer, it is a device set in a pipe to enable a Bourdon gauge or a manometer attached to the piezometer to show the net or normal pressure. So mo ni ang simplest form of manometer. Then capacity, it is the rate of flow of liquid measured per unit of time, usually gallons per minute, GPM, or liters per minute, LPM. So, kasagaran na itong nailhan is volume flow rate, pero gitawag ni siya pod og capacity. Then, suction lips. It exists when the total suction is below atmospheric pressure. Then, suction head exists when the total suction head is above atmospheric pressure. So, based on the picture, when we say suction lift, na the source, so kani nga tank, so suction lift na siya ubo sa pump center line. So as we see. Then when we say suction head, ang tank is above the pump center line. So mo naton timanan kung head, it is above the pump center line, and when it is lift, it is below the pump center line. Then velocity head is a measure of the kinetic energy contained in a unit mass of the fluid due to its velocity and is given by HV equals V squared over 2G. Then total discharge head, it is the reading of a pressure gauge at the discharge of the pump converted to feet of liquid and referred to datum, plus velocity head at the point of gauge attachment. Then total head, it is the measure of the energy increase per pound imparted to the liquid by the pump, and is therefore the algebraic difference between the total discharge head and the total suction lift exists. It's the sum of the total discharge head and total suction lift, and when suction head exists, the total head is the total discharge head minus the total suction head. So aron masabta na to, so let us demonstrate. So let us say, for instance, is the sum of the total discharge head and total suction lift. So kay ba matanga kaning Z1 mao na silbi ang kanang anhin na to, may bawaan kung suction head ba siya or suction lift, kay mao man silbi source. Then ang Z2 mo na ang discharge head. So if ever suction lift ni siya, it has a negative sign, so minus Z1. So nigbalhin mo sa pikas, mahimo na siyang Z2 plus Z1. Monang is the sum of the total discharge head and total suction lift. However, if suction head siya, so diri daan at left side positive siya, so inigbalhin niya sa pikas, mahimo nang Z2 minus Z1. So mao ni nga, the total head is the total discharge head, so Z2 minus the total suction head, nga Z1. Then net positive suction head in PSH, it is the total suction head in feet or in matter of liquid absolute determined at the suction flange and referred to datum, less the vapor pressure of the liquid in feet or matter absolute. Then let's proceed to centrifugal pump. So centrifugal pump, it is a pump in which the pressure is developed principally by the action of centrifugal force. So let us tackle the section 3.0 related to pumps. So the major classes and types. First, volute. Second, diffuser. So diffuser originally more efficient than volute type pumps. Today, efficiency of both types is about equal. So mo ang porma sa volute o diffuser. So then Mixed flow. So the mixed flow impeller discharges fluid in a conical direction using a combined radial and axial pumping action as suggested by the title. So mixed siya. Then axial flow. The axial flow impeller discharges fluid along the shaft axis. So for this reason, an axial flow pump is by definition not centrifugal in its pumping action. Then the other type is the turbine or regenerative. So they fill a need between other centrifugal and usually rotary designs. They are low to medium capacity, high head. Gear pumps consist of 2 or more gears, spore, single, or double helical teeth, while vane pumps have a series of vanes, blades, or buckets turned by a single rotor. Cam and piston rotaries are positive displacement units, giving steady discharge flow along with screw-type pumps, and related designs they handle a wide range of non-abrasive viscous liquids. Then the direct acting, these are available in many designs for handling cold or hot water, oil, and a wide range of industrial liquids of many types. In the power pumps are driven from outside through a crankshaft or other device. Then the crank flywheel, one form of reciprocating power pumps, so designated to distinguish them from power pumps. So pump classification. First, the centrifugal pumps. So the classification of centrifugal pumps. A centrifugal pump is a machine which the pumping action is accomplished by imparting kinetic energy to the fluid by a high-speed revolving impeller with vanes and subsequently converting this kinetic energy into pressure energy either by passing the fluid through a volute casing or through diffuser vanes. So kung through a volute casing, gitawag siya volute type mga centrifugal pumps. Then kung through diffuser vanes, gitawag po siya diffuser type mga centrifugal pumps. So, the classification of centrifugal pumps. So, pwede na ito ma-classify ang centrifugal pumps by geometry. So, shape sa casing. By inlet geometry, section entry of the pump. Then, by layout, yung position sa pumps and other. Then, by mounting, by operation, by liquid handle. So, kung sa man yung liquid nga gihandle. By material, unsa siya nga material made of. Then, by drive, unsa man ang gapa under niya, for example, electric motor ba? Then, submersible pumps. So, basic parts of a centrifugal pump. So, na ay stuffing box, packing, shaft sleeve, vane, casing, eye of impeller, casing ring, impeller, discharge nozzle. So, the impeller imparts velocity to the liquid resulting from centrifugal force as the impeller is rotated. Then the casing gives direction to the flow from the impeller and converts this velocity energy into pressure energy, which is usually measured in feet of head. In the shaft, transmit power from the driver to the impeller. So the stuffing box, this is a means of throttling the leakage which would otherwise occur at the point of entry of the shaft into the casing, usually not a separate part but rather made up of a group of small details. So, the stuffing box, so made up siya of packing. It's the most common means of throttling the leakage between the inside and outside of the casing. Then gland to position and adjust the packing pressure. Seal gauge, so called water seal of lantern ring, provides passage to distribute the sealing medium uniformly around the portion of the shaft that passes through the stuffing box. So this is very essential when suctional leaf conditions prevail to seal against the leakage of air. Then mechanical seal provides a mechanical sealing arrangement that takes the place of the packing. So basically, it has one surface rotating with the shaft and one stationary face. The minute close clearance between these two faces prevents leakage of liquid out or air in. Then, shaft sleeve protects the shaft where it passes through the stuffing box, usually used in pumps with packing but often eliminated if mechanical seals are employed. Then wearing rings keeps internal recirculation down to a minimum. So having these rings as replaceable wearing surfaces permits renewal of clearances to keep pump efficiencies high. So now let's tackle to the specific speed. So it is a type characteristic of centrifugal pumps and is defined as the speed in RPM at which a given impeller would operate if reduced proportionately in size as to deliver a rated capacity of 1 gallon per minute against a total dynamic head at 1 foot. So mo na ang equation sa specific speed. Specific speed of pump in RPM equals N, so rated speed of pump, times square root of Q, or pump capacity in GPM, over H the power of 3/4. So ang H is pump head per stage. Pump head per stage. Then, kung double suction siya nga pumps, ang Q is divide na to og 2. Muna itong i-substitute. Then, kung multi-stage pumps gani, ang H value is kanang divide na to kung pila siya ka stages. Then, affinity laws for centrifugal pumps. So, at constant impeller diameter, so Q1 over Q2 equals N1 over N2. Then, law A2, H1 over H2 equals N1 over N2. And law A3, power 1 over power 2 equals N1 over N2. Then, at constant impeller speed, so law B1, Q1 over Q2 equals D1 over D2. Then law B2, H1 over H2 equals D1 over D2. And law B3, power 1 over power 2 equals D1 over D2. We're in the Q is the capacity, H is the head, then kaning kilowatt, kW, it is the power. So, applicable ang law E1 sa centrifugal, angle flow, propeller, peripheral, rotary, and reciprocating pumps, while law A2 and A3 apply to centrifugal, angle flow, mixed flow, propeller, and peripheral pumps. And law B1, B2, and B3 apply to centrifugal pumps only. So, pump classification. So, aside from centrifugal pumps, we have the rotary pumps. It is a positive displacement pump consisting of a fixed casing containing gears, cams, screws, vanes, plungers, or similar elements actuated by rotation of the drive shaft. Then, reciprocating pumps. A reciprocating pump is a positive displacement unit wherein the pumping action is accomplished by the forward and backward movement of a piston or plunger inside a cylinder usually provided with valves. Then, deep well pumps. So, deep well may be divided into plunger or reciprocating, turbine, ejector, centrifugal types, and air lifts. And then, for the section 5.0, we have the metric pump formula. So, theoretical power in kilowatts. Power in kilowatt equals Q times W times H over 6,130.25, wherein Q is the pump capacity in liters per minute, W weight of fluid in kilograms per liter, H total head in meters. So, for cold water, W equals 1 kilogram per liter. So, mahimo na siyang kilowatt equals Q times H over 6,130.25. And for other fluids, the equation has to be multiplied by their corresponding specific gravity. So, mahimo ng kilowatts equals Q times H times specific gravity over 6,130.25. In the actual power required, so actual power required equals kilowatt, theoretical kilowatt over efficiency. That's all. Thank you.